Hello friends, my name is Dr. Ashutosh Jha. Today we will discuss about हाइड्रोजन. आज हाइड्रोजन के बारे में देखेंगे. सो हाइड्रोजन जो है इसका सिंपलेस्ट एटॉमिक स्ट्रक्चर होता है और जितने भी एलिमेंट्स हैं अमंग ऑल द एलिमेंट्स. इसके अलावा इन द नेचर एटॉमिक फॉर्म में अगर बात करें तो एटॉमिक फॉर्म में इसमें सिर्फ एक प्रोटॉन होता है और एक इलेक्ट्रॉन. सो इसका एलिमेंटल जो स्टेट है, एलिमेंटल फॉर्म है, उसमें ये डाइएटॉमिक मॉलिक्यूल होता है और डाईहाइड्रोजन इसे कहा जाता है. सो यू कैन सी दिस इज हाइड्रोजन सिंपलेस्ट एटॉमिक स्ट्रक्चर अमंग ऑल द एलिमेंट्स in the nature, and in atomic form it has only one proton and one electron. In elemental form it exists as a diatomic molecule which is known as dihydrogen. It forms more compounds than any other elements. It must be remembered that only the hydrogen is here, which does not comes under those compounds which form very less compounds. The hydrogen element forms more compounds. So these are here. Now, if we see what is the importance of hydrogen, so we must remember that the hydrogen is of great industrial importance, which you will learn in this unit. So hydrogen has very great industrial importance. It is used in uh, industries, um, also, and it can also be used as a source of energy also. So next we see the position of hydrogen in the periodic table. So what is the position of hydrogen in the periodic table? So if you see, hydrogen is the first element as we know in the periodic table. So its a placement in the periodic table have been the subject of discussion in the past. There is a lot of questions regarding the placement of the hydrogen in the periodic table. So, as you know by now that the elements in the periodic table are arranged according to their electronic configuration, as we all know. So, when we talk about the electronic configuration of the hydrogen, so hydrogen has electronic configuration that is 1s1. So, on one hand, its electronic configuration is similar to outer electronic configuration of alkali metals, which has the formula of ns1, so which belong to the first group of periodic table. On the other hand, like halogens, it is sort by one electron to the corresponding noble gas configuration, that is the helium 1s2. So the hydrogen has a resemblance to alkali metals, which loses one electron to form unipositive ions, as well as with the halogens, which gain one electron to form uninegative ion. So, like alkali metals, hydrogen forms oxides, halides, sulfides. Unlike alkali metals, it has very high ionization enthalpy and it does not possess the metallic characteristics under the normal conditions. So, in fact, in terms of ionization enthalpy, hydrogen resembles with halogens. Just for example, if you see the ionization enthalpy of lithium is 520 kilojoule per mole, fluorine is 1680 kilojoule per mole, and hydrogen is 1312 kilojoule per mole. So here you can see that the ionization enthalpy of hydrogen resembles with fluorine, not with lithium. So, and fluorine is a halogen. So, like halogen, it forms a diatomic molecule, combines with elements to form hydrides and large number of covalent compounds. However, in terms of reactivity, it is very low as compared to halogens. So, in spite of the fact that hydrogen to certain extent resembles both with alkali metals and halogens, it differs from them as well. So, what can be their placement when this question arises? What can be their placement of hydrogen in the periodic table? So, if we see this thing, then we understand that the loss of electron from the hydrogen atom results in nucleus H plus, which has the size 1.5 into 10 to minus 3 picometer size. So this is extremely small as compared to normal atomic and ionic sizes of 50 to 200 picometer. So as a consequence, H plus does not exist freely and always associated with other atoms or molecules. So it is unique in behavior and therefore best separately placed in the periodic table. So hydrogen does not placed in the periodic table. It is placed separately in the periodic table. So this is all about the position of hydrogen. So this was today's lecture. So we will meet in the next lecture. Thanks.